Hello friends, today I'm going to solve LeetCode problem number 899, orderly queue. So we are given a string s and an integer k, and what we need to do is we can choose any one of the first k letters from s and append it to the last of the string, and the results would be so that it is the lexicographically smallest string after we apply this method, and it could be applied any number of times. So for example, we have given cba and the value of k is equals to 1. We need to get the result which is lexicographically smallest by applying this move, that is by choosing one of the first k letters and appending it to s. So if I need to make it lexicography smallest, how can I do that? So let me show you here. So I have this, and k is equals to 1, which means I can only choose one letter and append it to that string. So when I choose C and append it to the string, I'll get something like this. Again, it could be even smallest, right? If this is smaller than C, B, A, we know that because B is smaller than C, and B is greater than A, so we could still move B and append it to the string so that we get the smallest one. So this is what we get here. So this is the answer for this one. Now let's look at this example here. So we are given b a a c a, and the val and k is equals to 3, and we also need the smallest one, right? And for k equals to 3 means among these three we need to move one of the letters to the end. So which one do you think, if we add it to the end, will give us the smallest one? Well, b is the largest one, right? B is bigger than a, right? So we could move b to the end. So if we move b to the end, we get c, a, and b. And then again, among these three letters, c is the largest one, right? So if I move c to the end, then this is what we get, and this is the smallest one because a, and a, which are equal, and then b is greater than a, so everything before b is smaller than b, and then c, which is greater than all of these. So it's kind of in an ascending order. If we look at the ASCII code of all of these, so these have the smallest one, and then this one, and then this one has the bigger one. So this is the smallest lexicographical order that we could get for this string. And what about this one? Let's see. So we are given 4, which means that we could move any of the characters around and append it to the last. So what do you think would be the smallest one? Well, it's basically like we are arranging all of these in an ascending order, right? So we could just do it directly, like G, V, X, and Z. So this will be the final result because Z comes before V, and V comes before X, and X comes before Z. So this will be the smallest lexicographical order that we want. And how can we reach this? So one way is we either choose the biggest one. Yeah, so since what we are doing here is let me show you here. So I have some values here, and then I am taking one of the values, adding it to the end, again taking the same another value, adding it to the end. So what am I doing is basically 1, 2, and 3. Let's suppose this is what I have. So if I take 1 and append it to the end, what I get is 2, 3, right? Again, if I take any of these, suppose I take 2 and append it, I get 3, 1, and 2. And then again I'll get 1, 2, 3 if I append 3 at the end. So basically I am pushing to the end, and my string pushing to the end, right? So what if in case from 1 to n3 I want a descending order, so I can still get it. Since 1 2 3 this is ascending order series, all I can do is I can take the value 2 and append it to the end. So 3 1 3 2, this is what I get. And then again I take the value 1 and append it to the end, and this is what I get. So this is the result, right? So basically we could what we are doing here is, if I want it to be in a decreasing order, I take the smallest, I take it such that my order is maintained. So what comes after 3 will go to the end, what comes after 2 will then go to the end. So basically I already know the answer and I'm arranging it in that way by picking it up in a greedy way. So this is what we will be doing here as well. So since I already know the answer should be like in ascending order, which means that I need to pick the smallest one and push it to the end. So basically what I'm doing is, from 4 I'm picking the smallest. Which is the smallest? It's z, right? So x, z, v and g. Now my value is reduced to 3. So now I know this is my lexicographically smallest. So now from these 3 I choose the smallest one. And which one is the smallest? Of course v is the smallest, right? So then I take v and then append it to the end, and now my k becomes equals to 2. So now these two characters are in lexicographical order. Now which of these two is the smallest? X is smallest, right? So z, g, v, x, and my k equals to 1. Now I have only z left, so k is equals to 1, which means that I take z and then append it to the end. So and that is what I get my answer. So basically what are we doing is, we are sorting all the elements in an ascending order, sorting all the characters of this string in an ascending order. Similarly, that is what we will be doing here as well. Let me show you in this example, it will be much more clearer here. So I'm given the value of k equals to 2 and z, x, m, v, I, which is the string given, and I know this is the lexicographically smallest string that I can get from this one, because he is small than any of these characters, I is small than any of these, m is small than v and x, v is small than x. So this is the smallest one possible. And how can I achieve that? Well, to achieve it from both of these, what's the smallest one? Of course z is the smallest one. So mvi, let's just move through intuition. There is no algorithm, like how could you do that? So my intuition is that if I add z to the end, then this is my lexicographically smallest so far. Now between these two characters, which is the smallest? So I pick m, v, I, z and then add it to the end. Next what I want is, I want something like this zmv. So after m, of course v comes, right? V is the smallest between x and v, so I pick up a v and then append it to the end. Next, between x and I, of course I is smallest, but then again look here. We see here that x comes after v, right? So that is, I need to pick x and append it here so that it comes after v. So I pick x and then what I get is this thing here. Now do we have our like lexicographically smallest one yet? No, these are lexicographically ordered, but this is not. So we still need to do some more iterations again. So now between z and I, which is the smallest? Z, of course. So I pick z and then I move z to the end. Next, now I is the smallest, right? So mvxzi, and then vxzim, and then I pick a v, so I get im v, this is the one, and in the end I pick x and I put it to the end, and then I'll get my answer, and which is this. Now let's look at wholesome. So what are we doing here? If k is greater than or equals to 2, so basically I am at the string as I'm just ordering all the characters in the ascending order. When k equals to 2, when k equals to 3, I'm also doing the same thing. I'm just ordering all the characters in the string despite the value of k being anything, but it should be greater than or equals to 2. Here also I'm doing the same thing. I'm just sorting all the characters in the string. Now what if in the case of k equals to 1? Well, in that case it's something different, because we see that a is less than c but c is not less than b. So this is not this string is not, all the characters in the string are not sorted, but this is the lexicographically smallest we could get from this when k is equals to 1. So basically for k equals to 2 or greater than 2, we are just sorting the string, and then for k equals to 1, I'm doing this calculation, so this process. So basically what I am doing is, this is my original string, and I just append my first character to the end, and I check if this is smallest, then yeah, smaller than this, then my new string becomes this, and then again I take this character and then append it to the end, and if this one is smaller, then I get my new string as this one. So and then again I check if this is, append this to the end and check is this smaller than my previous one. Like, let me just write. So I continue this thing. So what I do is a b cba. Now I check, is this smaller than my previous one? Of course not, which means that this was the smallest one, right? So I found my smallest one here, so I'll then stop it and then return my string, which is this. So let me just dive into the code. Now we have two cases: if k equals to 1 and else k greater than or equals to 2. So if k is greater than or equals to 2, it's very simple. So we are just sorting our string as dot sort and then return s, no matter what. And for k equals to 1, what I'm gonna do is I'm gonna use a temporary string and then assign it to s, and then for let I equals 0, I is less than s at length, I plus plus, and then why am I doing this, I'll just let you know in a second. Okay, answer, this will be my answer. Let temp equals to s dot splice, so I'm splicing my string I plus s dot splice 0 comma I, and then if temp is less than answer, temp answer equals to temp, and then finally return, finally we are going to return answer. I see splice. So now what am I doing here? Let me just clear you out. So I already told you that for CBA, right, CBA it's 1, right? So we basically are taking and moving it to the end, right? So A B C, a cb. So this is what we get from here. So what am I doing is the first one becomes the last one, so I'm moving I equals to 0 to the end. Now if I look here, this becomes my this becomes my string. But if from the original string, if I see, what I'm doing here is I'm splicing. So here I'm splicing my index starting from 1 all the way to the end, plus concatenating the same string with c, which is 0 comma I, and I here is equals to 1, right? I is equals to 1 here. Now here I'm doing the same thing, but what if this thing will give me this, so BAC. So this is actually resulting me in this string. But here in this case I am not actually changing my original string, I'm just changing my index I. So basically what I'm doing is now initially I moved only one character to the end. Now I'm moving these two to the end. So basically we are doing the same thing, like for k equals to 1, like I'm just cutting b and pasting it to the end. So it's similar, like we are doing the same thing if you choose. So now when I is equals to 1, which is starting from the second index, so a plus, and then splice 0 comma 2. So 2 is not included, right? So 0 1, so I'm splicing cb and pasting it to the end. So a cb, this is what I get. Basically that is what I wanted, right? So that's what I'm getting here. Instead of changing my original string, I am just changing the indices. So that's what happening here. And every time I'm checking if my answer is less than if the temporary result is less than this, then my answer becomes this one. And then again I calculate the new result, which is this. And if this is smaller, that is if temp is smaller than this, then my answer becomes this much. And I again perform the same. I only perform it when I is equals to plus 1. So when I equals to 3, it breaks, and then I find my answer. So that is what it is. Let's return run our code here. Okay, so what's wrong here? The splice is not the function. Okay, I'm not splicing, actually it's slice. I always get confused with this splice and slice thing. In JavaScript it's slice. I'm sorry about that. Well, what went wrong? I equals to 0. I do not need I equals to 0. I can start from I equals to 1. And still, yeah, I knew that. So what's going wrong? So when I equals to 1, 0 1 1 not including, so I append c. I equals to 2, I take these two characters and append it to the end. And when I equals to 3, it ends. And temp is less than answer. Temp, which is BA, and CBAC is less than CBA. Yes, of course. Okay, I'm returning my answer from within the for loop, which is not good. Okay, let's use some more example test cases, and let's add my test cases here as well. GXZV, GXZV4, and then run the code. Okay, so it is not a function. Well, because s is a string, so I should split it before I then join it. Now this should work. Great. Cool, it's 88%. Okay, so the time complexity here is n log of n for this one, and for this one it's the length of the string O of n, so basically it's n log of n.